Yeah, not about.
It's 20% of your grade.
It's not about. It's 100 questions. And some of the Jim's drawings are worth 3 and 5 and even I think 6 questions if you get them. They have components to them. Some of the questions are weighted at 2 answers. You'll see. We'll go through it really quick and you'll have a sense before we
You
do
got
it.
it. So you can go.
Yeah.
Give them tips.
Well,
Okay.
okay, later, Gator.
And if you can't make it, just email. So James, for your class in spring, there's no Saturday lab. It's Thursday nights again.
No, I think we're gonna change that.
Oh, you're
Yeah,
gonna
Rod
change
and
it?
I talked.
Okay, you're gonna change it.
Yeah, we talked.
Okay.
And he said he was gonna work on it, but he said there was only one person signed up with it.
Yeah.
So he was just gonna drop it and then reopen it.
Okay.
Hey Rod, do you know what class that was?
111.
That's a CT 111, and then I have CT 114, which will be Thursday nights.
Who's
And then
teaching-
Rodney and I will, I'll teach the lecture, and Rodney and I will take turns doing the lecture.
Who's teaching the 122?
The next Saturday, which should be really interesting.
I'm sorry, what was that again?
Who's teaching the 122?
Probably Patrick.
Oh, Patrick. Okay.
Oh, for you?
Yeah, we're taking Patrick's too.
Yeah, that's hopefully that's the only one I need.
Building green.
Oh, yes. I used to do a 119 class, which was a remodeling class, but I taught it as a green remodeling class. That was pretty cool.
You gonna teach over summer at all or no?
I usually just do my non-credit classes.
Okay, got it.
But we'll see. Patrick's leaving, so they might pull me in to do a class.
Okay.
Just when I thought it was off, they pulled me back in.
All right, thank you, James.
I just want to go to Costa Rica for this.
Go,
That'd be nice.
you'll be
No,
fine.
I can't. I got a big project coming up. I got a 8-unit contract.
Glad I don't. Thanks, Jim. Okay, let's have a safety meeting. Trailer and tongue safety. This is not like how to protect your tongue and not bite it when you're eating. Introduction. Trailers are used in many different industries for the transportation of goods and equipment. While trailers help with transportation, they can also expose employees and the public to potential hazards if the trailers are properly hitched or loaded. Employees need to remember that they are responsible for proper hitching and towing of trailers. Following the safe work practices presented in this lesson will help ensure employee safety. Okay, we are not going to read this. It goes through the components of the trailer, plus I'm not projecting it for you guys, so yes.
Yeah, that's my first question, but have you started recording?
I did, thank you. So I'm not going to project it, so you guys don't get to see it. You'll just need to go access it on Canvas if there happens to be a question from here and you want to look for that answer, right? We're just not going to take the time to do it. It's a good safety meeting because we do use trailers and I actually like it. I just don't want to take the time right now. Okay, so it's still sitting there for you. But I'm not doing it tonight, bless you. So week 12, this is week 12. What does that mean? Well, it means 4 more weeks. 4 more weeks, and then I imagine we'll do the final on the last night. So really 3 classes,
The final's gonna be in week 16 for this class or week 15?
16, the last class.
I know Patrick does his in week 15.
Well, I know, and I used to do that too, even though the school tells you in no uncertain terms, this is when you need to do your final. So
Right.
we were doing it before, so people could come on that last class, get their test back, and we could go over the test. But what happened over the years is that half the class didn't show in the last class. They did their final, they were done. They didn't feel like they needed to show. I couldn't get them to show, so we started having it on the last day, so people had to show and take the final. So midterm span review, midterm exam review. Where did I put the exam in here? No. All right, good. It's 100 questions. Yeah, he didn't put this double, so this should be 7 sheets. 6, 7 sheets. There's a bunch of true and false, right? Everything's based on the book, except the stuff we did up at City College, the pour and the forming. There's a few questions about that. There may be, I only put a few in, and that was mostly about that. And if I put in the 3 safety questions, let's see what else I got in there. But there's going to be, you're going to be asked about some questions from the quiz, like the depth of how much deeper your saw blade should be than the work you're cutting. Remember that one? Easy one. The good housekeeping thing, what a 3, 4, 5 method can be used to verify. Again, pretty easy. The standard stud length for an 8-foot ceiling with a 1.5-inch bottom plate. Do you guys know that, what that is? Did he ever go over that with you? Probably. Standard studs, because because if you go to the board store and buy a stud, you buy a stud that's 92. You're gonna have a question on the test. Just make sure you know that that's the answer. And how does 92 1/4 work? Because 92 1/4 plus 4 1/2 is 96 3/4, right? 96 3/4. That's what that is. That's what that equals. So how is that an 8-foot ceiling? Well, when you have your ceiling (96 3/4), when you put 5/8 drywall on top, then you can put an 8-foot sheet of drywall and keep it off the floor by an 1/8 inch. That's pretty much what it does. It's higher than 8 feet, so because you always run your lid first. Always. Yeah. Do you know why? Daniel?
Yes.
I knew that was you, Daniel. Have I seen, is Jesus, have you shown up? Christian Guzman? Gadiel? Okay, you got that?
Those are, yeah. No, they're not mine. We got lucky on. Yeah.
Okay, so, what am I doing? Yeah, let's go here.
You're giving us more midterm answers, I think.
Yeah, that's exactly what I'm doing. You're totally right. The 3, 4, 5 method, you guys know what that is, right? What is it? Somebody. The reason you triple the studs at the corners. Remember that? Remember why you do that? You do it to provide nailing for drywall, to make it easier to nail the 2 walls together, and to provide backing for sure. You're going to need to know how long a 16D common is. 3 1/4. You're going to be calculating the board feet in a 6 by 14 by 112 inches long. So the easiest way to do that, by the way, well, yeah, I would still change it into feet before I did anything. Gadiel? No. No, that's Alex just came in. Didn't recognize your glasses on, Alex. So you got a board foot question there. And now let's just do it. We'll do something similar, okay? You're gonna have something similar to this. The 8 by 16 by 118 inches. That's not the exact question. It's different than that. But here's how I would do this. Eight times 16, do that on your calculator. It's 80 plus 48, so it's 128, right? Right? 128. 12 into 128 goes 10.666, or 10 2/3. Right? 12 times 10 is 120, and 8 over 12 is 2/3. So this is, so for every foot, it's 10.666 or 10 2/3 board feet for every foot. It's 118 inches long, which is 2 inches shy of 10 feet, right? So that means it's 9 foot 10. That's 10 over 12. So somebody do 12 into 10 for me. It should be 0.125, right? 0.12. Yeah. Okay. So what you got is, oh, I'm sorry. 10 over 12 should be, that's 5/6, right? And 6 into 5 is still, yeah, 0.12, right? 0.12, that's not right. Something's wrong there.
Isn't it 0.875?
Yeah, that would be, no, it's not. I don't know why I'm looking blinking so bad. Oh, and also, pardon my French too, please. It's not real French. 0.83. All right, I just gotta figure this out here for a second. So 9 foot 10. 10 divided by 12 equals, yeah, it's not, it's 0.8333. So that equals 9.833 feet. So we're gonna take 10.666 times the lineal feet, 9.833. Numbers wrong here. 10.666 times 9.833 equals. Okay, we don't want board inches, we want board feet. Nobody buys anything in board inches.
And then should we always go just 3 decimal places?
Yeah, you don't need to go ever any further than that. And that's probably way too many. It probably should be 0.88. But yeah, go 3. But you see how I figured that? Because you're gonna have a similar question to that. It's gonna be in inches. It's not gonna be in feet. So you're gonna need to turn it into feet. And if that happens to be, some of the easier ones like 10 inches is 0.8333. And it's just anytime you get that, right? Anytime that you get inches, any amount of inches, say 7 inches, and you need to convert that to feet. And always the bottom numbers always divide into the top number to get a decimal. Always. So just turn it into a fraction and make it into a decimal. And you've got a calculator, so you should be able to do it really easy. Same thing with, your question is gonna wind up having 4 inches. That's an easy one. That's 1/3 of a foot. So it goes into 12 feet.
So all 3 of the numbers will be in inches.
Yes. On that question, all 3 will be in inches, so you'll need to convert them to feet. And then you can convert them in feet and then just, multiply all of them over 12. I like doing it this way because I like to find out the board foot in a foot. And then it's easy for me to just buy the lineal feet times the lineal feet. Once you figure out 1 foot. So any board foot equation, I think the best is thickness times width over 12 times lineal feet. So it's thickness in inches times width in inches over 12 gives you the board foot in 1 foot times the lineal feet. And that's always in feet. And then you're going to be talking about the typical floor plan drawings, what the scale would be. What is it? Yeah, exactly. According to a foot. Floor plans are going to do what they show, right? Bunch of stuff, and lists a bunch of stuff they show. Give you a hint to all of them. And then when we squared up, okay, this is my question. When we squared up our form for the shade structure at SPCC, for the Saturday lab, we use what method to check the form for square? Very good. Acorns. Damn it, I need some acorns.
When you said the scale was 1 1/4.
No. What is this, what is the standard scale for floor plans? Yeah, quarter inch per foot, there is no 1 1/4 anything, right? Quarter inch per foot, that's like, so just know that most floor plans you're gonna look at are gonna say a quarter inch per foot in terms of floor. Remember that thing about a builder's level? I have a mistake too. Remember that thing about a builder's level? What it can do? Just you're gonna have a question about a builder's level, so look it up in your index. And that's the other thing. You get to this question here, and it says a builder's level can, and there's 4 possible answers. And it doesn't just leap out at you, or you're still kind of wondering, is a builder's level a dumpy level? Is a builder's level a transit? What's the difference? What do they do? Just go to the index of your book and look at builder's level and go to the page it tells you to go to, and then read it, and you'll have a question answered.
I think James has some things
I think he does too.
in the drawer.
In the drawer. That's where they were, but I don't remember seeing them. a
He
while
pulled
back.
them out last week and put them on my square.
I hope they're back there or on a square. So, and then installing, and then I put something on about a circular saw blade. That's a good one too. And then he's got, then you've got 6 true or false ones, batter boards, how far away from the corners, how far away should they be set from the corners created by the building line? 4 feet. I think that is it, actually. But you know, what? I'm not going to commit. I think this is a false answer, but you guys,
Did he put 6 on there?
6 what?
6 feet.
No, it's got 6 inches. Reinforcement monolithic concrete, and then monolithic concrete comes from Mono County, California. That's kind of a gimme. In most areas, concrete sidewalks are 4 inches. Number 5 rebar. Number 5 rebar is very good. So you're gonna know the answer, whether it's true or false, because you all knew what that was. It's gonna ask you about the reaction of cement and water, what it's called. Very good. And then what, open truss joists, wood I-beams, did you hear, you didn't hear her? I didn't.
No, I didn't hear that.
So there's a chemical reaction of cement and water that happens when you're making concrete, and it's called something. And Claire said what it was. What was it, Claire? Very good. Did you get that now?
No.
Do I need to spell it for you? Fucking name, confused? This is it. This is done.
What did you say?
Hydration. And then there's a question about what's used as shear paddle. That's a really easy one. And then I put this one in. The size of the rebar we used for the SBCC straight shade structure slab was, I give you 4 choices. I think you'll get it. Can somebody tell me what the top mat and the bottom mat was? What did we use? What was the size of the rebar? Nobody remembers the size of the rebar?
Number 3.
Oh, yeah. You guys should all ace this test. He's got that question on here is the coach size for a foundation bolt washer. There it is. Measure it before you leave.
That's a repeat.
3 by 3.
Someone want to measure it and say it out loud
Yeah, what do you got?
for Sacramento?
3 by 3, and it's by call it 1/4 inch thick galvanized.
Thank you.
And in Santa Barbara coach size, it's actually slightly different than that, but that will get you the right answer. Column footings, after our 4 column footings were laid out and dug, just prior to pouring, it was important to do what? You'll know. You'll see those things. He's got you calculating the length, the line length of a rafter with a span at 46 feet, and the slope is 10 and 12. So let's do this. I'm not going to show you that. We'll do another one. Oh, chromium eraser. That's what I'm stuck with.
You want to use a rag and a spray?
That's better. Did you guys get Jim's? Everybody get Jim's thing? I will post it too for the people that need to get in touch with him.
But not Milwaukee. Right? Or AOL. David.
That's the,
The stuff you think?
Just toss it.
no, that's the busted pen.
Toss it. Can you make it?
Yeah, I was aiming for Alex's elbow. You okay, Alex?
Move direct there.
Okay. That's Jim. Now, this question is gonna be a little different. The line length, 6 feet. Okay, so let's do this. We'll do span. It's 48 feet. We need to know the line length of the rafter and the slope. In this case, we'll call it 8 and 12. Right? So that's slope, and that's how slope is written. So it rises 8 inches for every 12 inches of run. 48 feet is the span. What's the run? 24. Exactly. 24 feet of run. So when you're asked to find the line length of the rafter at an 8 and 12 with 24 inches of span, what you're going to do is you're going to go here to 8, under the 8 and 12, right? And you're going to read this top number. That top number right there, 14, right under the 8. Under the 8, because it's 8 and 12, right? See that? Under the 8? See that? Under the 8. It's 14.42. What that's your multiplier. So 14.42 is your multiplier, and we found that very easily because we know it's an 8 and 12. So we just go to 8.
So you go to the rise always?
Always.
Whatever the rise is.
Always.
You'll do.
Because it's something in 12, right? So that's not the question. The question is another rise, which is on here. This one we're doing this problem right now is 8 and 12. So there's your multiplier, 14.42 multiplied times what?
24.
Exactly. Times 24. And that's the line length of your rafter. And you see how that works, right? You see how that works? Because with an 8 and 12 slope, so here's 12 inches of rise, right? If you've got 8 inches, I'm sorry, 12 inches of run. If you've got 8 inches of rise, it extends that line from 12 to 14.42.
Do you want us to subtract like 3/4 of it for the ridge?
No, line length. The line length will be the multiplier times the span. All right. You guys come up with whatever he gives you in the question. He gives you the slope. Come up with wherever that slope is. From all the way from 18 and 12 to 2 and 12. It's somewhere in there. Right below it, that top line is the multiplier for the foot of the run, which is half span. Okay, and that
And that gives you the inches of the rafter.
that will give you the inches of the rafter. Yeah,
Is 12 not important for that? All you need is the rise, right?
It is.
correct. 12 is not important. 12 is not important.
Rodney.
Yes.
Are we gonna have to take into account half the width of the?
No.
No?
Now, when he calls out line length is center of ridge to outside of plate, right? So line length, when he calls out line length of rafter, that's outside of plate, the center line of ridge. That's all you need to know. And that will be half your span. Your span is outside plate to outside plate. That's your span, half of that's right smack through the center of the ridge. That's your run.
So when you're cutting your actual rafter, you subtract 3/4 of it. Right? Yeah. But for the line length, you don't have to touch it with that.
No. No. There's all these things when you actually do it. You come up with numbers, and then when you do it, there's other things you gotta do.
So the line length would be 346 inches,
I guess.
just whatever that is.
Turn that into feet, though.
You have to keep it.
Yeah, definitely don't give an answer in inches. Nobody's gonna, if somebody wants to know, well, how long is this rafter? And you say 300 and some odd inches, they're gonna go, you're fired. Next, how long is this rafter? Okay, use framing square tables. Identify the parts of the rafter illustrated on the right. So he's gonna ask you where the tail is, where the seat cut is, where the plumb cut is, where the tail cut is, where the bird's mouth is, where the double top plate is, where the ridge is, and where the line length is. It's okay. Really, we just talked about all that stuff. And it's all in your book too. Really easy to find in your book. There's a question here about FSC and what it means. Anybody know what it means? I'm going to say it out loud. Forest Stewardship Council. That's what FSC stamp lumber means. Okay, now 52.
Wait,
and
can you repeat
53 is
that,
worth-
please?
I'm sorry.
Could you repeat the FSC?
No, I'm just giving you answers. If you didn't hear it, you're SOL. Just
Wait,
kidding.
no,
Forest Stewardship Council.
stewardship? Or what'd you say?
Sewership, yeah.
Stewardship.
No, stewardship. Like stewardship. Do I need to say that 4 times now?
Can you write on the board?
No. Right, if the line length of the rafter is 278.98 inches and the span is 38 feet, what's the slope of the roof? Well, he's just asking you to work backwards, basically. So what you need to do, I don't want to give you the answer to this, but on this question, 52 and 53, you just need to divide the feet. Wait, because that's the span. You need to divide the run, which is half the span. If it was 38 was the span, then the run would be what? You mean 19? Is that what you meant? I thought so. You just need to divide that run into the line length of the rafter. So he's giving you the 273.98 inches, right? And you divide the 19 into that, that's going to give you a number. And that number you're going to need to look for on this top line. And wherever that number hits, go, oh, right above it is going to be the slope of the roof. So if with whatever that, I have no idea what it works out to because I need to do the math, but if it works out to say 13, if that goes into it 13 times, look under 13, it's 17.49. Right? Oh, I'm sorry. You see that if it works out to 17.49, then that's what's under 13, then you know it's 13 and 12. So just work backwards, but that's a question right off the to square. And you just have to work the numbers backwards. That's all. Remember that. When you get that question, what the heck? Line length of so many inches and the spans half the run, get the run, divide the run into those inches, and that'll come and you'll find it. Find that number. I do it for you right now, but I don't want to. Okay, and then you got a bunch of true and false, like 7 true and falses. Pretty easy. Talks about doors. Talks about some door openings. Like he says a 2.8 door is 30 inches wide. Is that true or false?
What door?
2.8.
Yeah, false.
Yeah. Why is it false?
2 feet by 8 feet.
Yeah, I mean, what's that in inches?
24.
26.
Come on, a 2.8 door is how many inches wide?
2-foot door.
2'8" door is how many inches wide? I'm gonna say this,
My
I'm
bad.
gonna keep saying it.
Oh, I thought.
2'8", how many
32.
inches? Is it 30 then? No, that's why it's not.
Sorry.
That's all right. I know, you get that, I get that stuff in my head, it's like, yeah, I'm telling you the answer, I'm telling you the answer. The most common spacing for floor joists and studs for framing walls is, you guys all know that, it tells you the answer here, and I don't, it's not right. Typical stud for framing walls is, no, a typical stud
The length,
is blank inches long.
92 and a quarter.
Very good. Okay, a good rule of thumb for figuring studs is, I put this one in. Exactly. Remember? What's a good rule of thumb for figuring the amount of studs?
Divide by 16,
No,
like the whole length.
no.
What?
God.
1 per foot.
Exactly. Thank you. 1 per foot.
I thought it was every 16.
It is,
But just
but 1 per foot gives you corners, partitions, blocking, when it gives you all kinds of stuff. So you figure 1 per foot. That's the rule of thumb. 1 per foot. I had that matcha tea again tonight. Saving it for Tuesday nights. Okay, minimum for rebars, minimum lap for rebar. It's gonna ask you that. He tells you, he says it's X amount of times the thickness, so you need to know what that is. And, you know, again, it's one of those questions where you read that question and you didn't know the answer. You just go to rebar on the index, look it up. Just read a little bit about rebar. And it's right in there. I just saw it. Here we go. Yeah, right there. Okay. It's all in your book. Here's another picture that Jim wrote, or Jim drew. And he wants you to identify stud, bottom plate, header, cripple stud, trimmer, top plate, corner. Piece of cake. They're all lettered, and you put the letter where they go. Cantilever joist extend inward at least length times the distance. And then he also asks you about checking a building for square, the best method, and he tells you it's not the 3-4-5 method. And then he's got some questions about the pour, what that board was used at the long pole to level it further, and the first level to make the concrete level with the form boards, what that's called. Well, after placing the concrete, what was the first method used to make the concrete level with the form boards? What was the first method used? Screening. Very good. See, Trent, you're on top of it, dude. How'd your concrete hand work out?
The fingers cracked off.
Oh crap, that's in there. You should have got some steel in there, man.
Yeah, some wire maybe.
That's some wire. Okay, after we use the board, the end of a long pole, concrete, this is a bunch of those concrete questions. Talk about, then he's got a question about a gable roof, what's a rafter called that hangs out beyond the gabled end? You guys know what that is? It's an outrigger. And that should be easy to find in your book. And then he talks about the boards that are notched into the other rafters or cantilevered out that support the answer to 76. He asked you what 3 things a strong back does. And I'm going to let you read that in your chapter 12. He wants to know what we call the supports that go from 81 to a main support wall. And 81 is what is a plate that supports long runs of rafters at their midpoint, sometimes added when a heavier roofing material is used than the original. Remember that one? You're looking for me, I'll have to look to find it for you myself.
Like a hanger?
No, it's not a hanger, but just know that you want to, have that book ready to open to wall framing. He's got a question on how thick is number 10 rebar?
1 1/4.
What is it?
1 1/4.
It's a heck of a rebar to cut too. You're not gonna do that with
What is it?
a
Is
dart
it?
cutter.
I thought after like 1 inch, it doesn't, like the 1/8 scale goes away. Or
Where'd you read that?
I don't know.
I haven't heard that.
It always stays at the 1/8.
I haven't heard that. If you find it somewhere, let Jim or I know. This is a great question. A simple hand tool, a blank. It's actually two words, is used for establishing a vertical line and finding a point directly below another point. Do you know what that is? Bob? Yeah, good. The actual size of a 2x4, please don't anybody ever miss this again. What is it?
1.5 by 3.5.
And then he's got a picture of a concrete slab, 34 by 26. He's got he's got a perimeter footing all the way around it. And it's a 6-inch slab. He wants you to figure the concrete net and come up with an answer in cubic yards and show your work. If you show your work and you get some of it right, or at least he sees you're trying, he will give you partial credit. Because this is worth 89, 90, 91, 92, 93. That's 5 answers. I mean, that's worth 5 points right there. This thing, just to figure cubic yards. And so he might give you partial credit if he sees, that you know some of the stuff that you're figuring. For instance, if he happened to saw that you came up with a number and divided it by 27, you'll probably get something right. But you do know how to figure cubic yards, right? Does anybody have any questions about figuring cubic yards, or don't know how to figure cubic yards? All right, so in this pour, you'd want to take the perimeter and go 1/6 times that 1.5 times that is 1.5 wide, and then he's got the depth there times 2.5. So those 3 are multiplied, and that gives you the cubic number. And then you can do the slab at 6 inches, which should be 0.5 feet. And then add that all together, and then divide it by 27, and you should have the yards. Just remember that you got to turn your square numbers into cubic numbers. So once you get the area, you got to add the depth or thickness, and that gives you the volume or the cubic part of it. He's given you a very similar plan to that one he did on the quiz with the elevations for the 4 corners. What should be the height of the string on the ground at the 4 corners, assuming height at the highest point, the minimum height for code. What's the minimum height for code on that slab? Yeah, 6 inches, right? Remember that, 6 inches. So if that's your minimum, don't forget to subtract it and go from there, right? 6 inches is your minimum slab height. And then I put 3 questions from safety test, and I've told you which safety meeting and what the date was. So if you're having trouble with any of these, it would behoove you to click and open them, the canvas, go to it and find the answer, because I've been pretty verbatim about writing the questions exactly how it's worded on the safety sheets. So don't trust yourself, because some of these might be a possible right answer, but it's not the right answer because it's not the answer from that sheet, right? I might throw in an answer that's conceivably a right answer, but not the right answer, because I want you to look for the words. Okay, and pneumatic tool, PPE easy. And then for extra credit, he's got you calculating the number of bags to figure the concrete for 89 through 93. It's a pretty easy one, really. If you've got the right cubic feet, right cubic yards, you'll need to turn that back into cubic feet and then divide your 0.75 into it, and that'll give you how many 90-pound bags, right? Because he's telling you that a 90-pound bag of concrete is 0.75 cubic feet. You're going to already have answered that question and gotten cubic yards. So you need to just translate the cubic yards back into cubic feet and then divide 0.75 into it, and that'll give you the amount of bags. That's your test. You're done. 100 for 100. Everybody got that right? Cool. Okay. So what we're going to do, everyone, is we're going to take a break. We're going to take a 10-minute break, 10-minute break. So 5 after 7. Then when we come back here, I'm going to start setting this stuff up. We'll zoom on this stuff that we're setting up, and then we're going to cut the zoom off and fire it up outside, and we're going to make some sawdust. Yay. In the meantime, if anybody wants to, you can take a pocket knife and cut those bands, and some of that stuff's got to get pumped out into onto the horses.
Hey, Rodney, these clothes are left for the day of the pour or the Saturday before the pour?
Day of the pour.
Oh, okay.
Somebody remind me, please, about about record. We're back recording. Okay, so Evan just took out the beam cell. We got the beam cell running. We'll go through this thing with you. Beam cell is out there running. We'll use a frame square clamp. I kind of like to clamp. I like to clamp something. Well, we'll work that out. I'll work that out. Okay, so. Okay, can I get some quiet down, please? Quiet down. Please. Give me a half light. Did Jesus, did you show up? Jesus Garcia Zambrano? Christian Guzman? Okay, so here's what we've been doing. It hasn't changed a whole lot from my first drawing, but I just want to show you how we're going to change this and all the figuring I did today. So right now, this slab is 15 feet and it's right on 15 feet. The posts are 6 inches in, right? So I show this beam at 6 inches past on both sides, and that's using a 16-foot beam. We have an 18-foot beam. We're going to square it up. We're going to probably take 6, 8 inches off. We'll make them both exactly the same. We're going to hang them both over exactly the same. So for instance, let's just say we wind up getting 17.6. That we get both our beams to cut to 17.6. They'll still sit exactly where they're sitting. The rafters, the 9 rafters will still sit right there, and because that's going to carry our roof. And our beam will cantilever a little further. Because so right now, at 16 feet, it cantilevers a foot past, right? 6 inches and then 6 inches past the slab. That's at 16 feet. If we go 17.6, we're going to be, we're going to be past the slab. We're going to be 16. We're going to be 1.5. We're going to be 9 inches past. We'll be 9 inches past. Is that it? No, that's not right. So at 17.6, from 16, that's 1.5 feet. Yeah. So from 16 rather than 6 will be 2 feet past. But regardless, but all you need to know is that whatever we come up with for those beam dimensions, it will be exactly the same length. And then we will measure to, because I have this dimension right here, from here to here, I've got that. All the dimensions at 2. It's a pretty important dimension. I've got that dimension at 157.25. 1.5. We can lay that guy out. Yeah. And none of this, other than cutting our beams to length and cutting our posts to length, and we might have time to rough out the rafters. We're not doing any more cutting here other than routing. We're going to route here. So with our post cut to length, we can erect our posts. We can put some SDS screws in the bottom of the column bases to hold them upright before we totally dial them in. We're going to get them plumb. We'll have enough people to plumb them up, and then we'll have our column caps on top. We'll drop our beams on, which will be pre-cut, pre-cut posts, pre-cut beams, and then our rafters will be roughed out, and then we'll make sure our bird's mouth works on site, and then we'll cut our bird's mouth on site. So to work out those bird's mouths, well, at this point, I had this going. I changed it once from 6/8 to 7/8, which would be 10 inches of rise, and that 5-footer run would have given me a 2 and 12 pitch. But as it turned out, I decided to do a 2 and 12 pitch using 10 inches. Well, I was thinking about 6 feet. It's not 6 feet. It's actually 5 feet. It's 5 feet. And 5 feet is basically from here to here. So I called that our run from outside to inside at 5 feet, and we gain 2 and 12. So in a 5-foot run and a 2 and 12 pitch, we're gonna rise how many inches? Yeah, 10. 5 times 2, 10. So it's going to be a 10 rise. So ergo, this post will be cut at 6/8. That's the post. 9.5 inch header set on top of it, making it 7 foot 5.5. This post will be cut at 8 3.5. That should be a line continuing there and a cross hatch. That's 8 3.5. That's the length of the post. And then add 9.5 inches to that, you come up with 7/6. Right? Is that true? No. What have I done? I screwed something up in that. Didn't I? No, that's right. So this post is cut 6/8. This post is cut 7/6. That's what it is. 6/8 for one post, 7/6 for the other. What's the difference between 6/8 and 7/6? 10 inches, right? That's our 10 inches of rise, 5-foot run, because it's a 2 and 12 pitch. I laid this out to scale, pretty big scale, 1 inch scale. That's as big as I could get on that page. Showed the slab, showed exactly where these column bases are based on the measurements I took on the slab, not just what, not just my drawing. I went and measured the actual slab. So that's all laid out. That 66 and 55 are per scale. So I laid it out big enough where I could figure what I wanted for a bird's mouth, which was 1.5 inches down and 8 3/4 over on the flat, should give us the bird's mouth we need. If I just put our acorns on the square, when we get our rafters, we'll find out where this is, because our rafters are going to center too. We're going to center on that. So we'll probably do this on site when we get our posts up. We'll figure out exactly where this part of our bird mouth is going to be. And this part of our bird's mouth, we'll cut a test piece, 2 of them on a piece of waste stock. Make sure it fits in there like we want it to, nice and makes contact all over it, 1.5 inches down and 8 3/4 across. And our post will be plumb. And then from there, we'll lay out, we'll cut them all. There's only 9 rafters to be cut on the site, so I'm not too worried about that. And one thing that I think I mentioned here, I'm not sure, I mentioned it more than once, to more than one person, but a 6'6" by 15-inch slab, 15 feet slab, 6'6" by 15-foot slab. 4 columns, 6 inches in all the way around, 2 headers, 9 rafters, 8 pieces of roof, 4 column caps, 4 column bases, steel and foam. It's a fairly simple structure, but there is nothing simple about it. There's nothing easy about it. There's nothing simple about it. All along, this is not like falling off a log. It's like, I'm having to figure. Now, I don't think it's just me. I'm not sure somebody could just, oh yeah, just throw that thing on. I think, I take a little more time than some people do and stuff, because I'm such an OCD perfectionist, and yet I can let things go. So it's taken a fair amount of time, but so far we got a really nice product, and I think the structure will just come out really good and be a blast. And I put a fair amount of time and thought and energy into it, and you can see when we're working in a fairly decent sized scale, 1 inch equals a foot. It looks as though that flat part of my my level cut of my bird's mouth, it looks like it'll plane pretty good right to the edge of the board. But really, when we blow it up, now that's 1 inch equals a foot. I blew this detail up to 3 inches equals a foot. And you can see the 1.5 inches and carrying that guy out, because this is the proper angle. I also measured this with my protractor. It's a 9-degree angle. That's what that creates, a 9-degree angle. And it goes flat for 8 3/4 before it exits the board at that angle. So it'd be fun to see that once we get a couple or a test rafter cut, we get the bird's mouth cut just to see how it fits. And I was thinking, out there, we could conceivably, because we know it's 10 inches of rise, right? We could conceivably cut 6x10s, lay one down, block one up 10 inches, move it 5 feet apart, and have, play with it there, rather than have it, up in the air, and make sure it works. And if I can assure myself that works there, we may cut the bird's mouth here. We just haven't decided yet. This is our roofing. I went over there today and laid out some laps with 1 lap. So with this guy here, if you can picture that guy there where my cursor is, lapping over the next sheet, like if that was the next sheet, it would lap over right to there. Then here to here, trough to trough is exactly 24 inches. So that's how we'll lay out our rafters. Dead on 24-inch centers. And and when we do lay them out, we'll actually lay this one out first. We'll lay them all out before we do anything. Make sure it all fits. But we'll lay that one out, and then we'll go from edge of that. So we want the roofing to go to the edge, 24 inches to the center of that trough, and then we'll go 24 centers. So this will be a little less on the side. That's got to be taken into account too. Okay, so is everybody ready to go out there and cut? And we get to do some cutting, and then maybe we'll do some routing. So what's going to happen, Zoom gang, is that can I have Zoom going? No, I can't. So I am going to unplug the camera, right? I'm going to unplug the camera. No, just this. I've got to unplug it from here and take the whole thing out. So I'm going to unplug the camera. So you'll be blank, but I'm going to pull up Zoom on the other computer and plug the camera back in, and you should be fine. So just don't go away, okay? Don't go away. Okay, off with that. Let's go get unmute myself.
How much
You
was that
guys-
saw blade? Like $200?
Okay, we're recording. That's good. You will go gallery view. Okay, there we go. Can you guys hear me okay out there in Zoom land?
Yeah, we can.
And you can see too, right?
We cannot see.
Can't see.
I can see.
I can see you.
Oh, sorry. Looking at something else.
Were you lying, Zach? You were just mistaken, right?
No, I think there's 2 users with your name.
What?
Actually, I have no idea what I'm looking
I
at.
know there is. I'm up there twice. I don't know why. That's okay. Yeah, I probably am, but that's okay too. Okay, it's just as long as you guys can see, right? Can you guys see? Can you guys see what we're looking at?
Yeah, we can.
Yes.
Okay, cool.
That's like probably it's
Yeah, that's probably long enough.
Yeah, that's probably it. For sure. All right, so what we're gonna do is we're gonna square, yeah, that's exactly right. We're gonna square this up first. So somebody bring a framing start
Yeah.
and a pencil. Pick up pencil. Yeah, perfect. Down. Almost reached that. Really close. Closer than most pencils people do.
I'm gonna move this like right where you're standing, do down there.
So what we'll do, this is a good end. Like this end. Got some checks. I gotta grab a tape. And some kind of a straight edge that we can clamp. So we go. Is it coming up on the screen?
Yeah, I got you framed up good.
I like that. Okay, so somebody find me semi-short piece of 1x next door in the shop, not 2x, piece of 1x that's very straight. Let's just see one out here. And maybe a 2-foot piece, 3-foot piece, or just bring it out here and we'll cut it. So we know we gotta cut some stuff off of here. We want to get rid of this stuff. Can you see that? See that from there?
Not really.
Gotta get rid of that stuff. So let's go ahead and get rid of this stuff first. And pull me a cord, please. Get rid of this stuff first. We'll take the checks on. All right. There. And then how much you have to cut off? What? It's gonna be 9 3/4. I want to get rid of this crap. That's 9 3/4.
These cracks.
Yes. No, they're called checks. The wood is checked where as a moisture leaves the wood, if it leaves fast. This is 18 2.5. That's cool. Like that. And so if we square that in, we should be able to we'll get past that check. We'll get down to here somewhere. Hold me on that, on my line, please. All the way down to my line. Yeah, so we should, we won't get 17.6 I want, but that's fine. I'm glad I got 18. So or maybe get 16.9. That's good. Whatever we get off of this. As long as we don't cut it under 16, we'll be looking good. But you can see, right, that we got to get rid of this. It's got to go. How'd it go? And we've got a nice square line here.
The final house is 16
What's that now?
feet long. There's no overhang on these. Like for lengthwise, it's just 16 feet.
No, you were listening. It's 16 minimum. And we want more, we want to have a little bit more. 'Cause we have more. Want to see my tape? Is that right? Thanks. Well, hoping we're gonna get a square cut here. And if we part of the saw that gives me the most purchase on the board. And I want to cut to the inside. That side. I'm going to cut to the inside set of the tooth. So inside set of the tooth. 5.5. Wow. And I don't have to be like killer accurate at this point. I'm going to make a mark at 5.5. I'm going to make another square line. Oh, I didn't need that. And then I'm going to clamp this guy on there. I think we're going to clamp this guy on there. The truth is, yeah, I think we are. We're going to be able to. Well, we're going to find out right now. Yeah, tight. Tight. Okay, square. So let's see. It's pretty deep. How deep is that? Deeper than we need to go. Say an inch over. Only when we're about a half inch. Or maybe quarter to a half inch, a little more down. Or even 2 inches. There it is. Right there, that's good. You like that?
About a half quarter.
Half inch. Yeah, I like that. Go this side. Oh, this blade is so sharp. Okay, sure. And then let's hear about that line. Yeah, well, I don't care about that line. So you guys understand, I don't really care about this line. If I'm this side or the other, it's just to square my board up. It's wherever it is. I'm cutting off this much to get rid of this bad piece of board and the big checks going through it. So I don't really care where it is as long as it's square. It's this side of the line, that side of the line. This is not, doesn't mean anything. My clamped guide is on a square line, so it should cut square. Plug it in. Yes, please. And then I need somebody. Now remember, you're gonna get the cut's gonna be this way. So I need somebody to grab this before it splinters and breaks off, before it falls off. Okay. Who's gonna do it? This is the thing about corded tools. You gotta know where the cords are. So not only do you need to know where you are, you need to know where the damn cords are. Okay, here we go. Ready? Go ahead. Remember what I said about don't move your saw until it stops running. Okay, so
That blade works too good.
well, it does, but it drifted.
How can you tell?
Thanks, look at my line. It got a bit of a drift and it cut right on a little.
Like a drift. You see
Yeah. And partly because this is a 60-tooth blade versus a 32-tooth blade, which would have cut a lot faster and probably wouldn't have done any drifting. This is a pretty hard part of the board. Can you come around here, Lou, and show us this? This is a hard part of the board because we cut into a nut. We cut into, that's where a branch is growing out of the tree. That's fairly hard. And we got a bit of a, sorry about that.
No worries.
We got a bit of a drift, but I think I'm gonna leave it because it doesn't affect anything. It doesn't butt up to anything. And we're gonna chamfer it. I think it'll all clean up really nice anyway. And I don't know a way to get that thing not to drift. It's not that bad. That's bad. Yeah. Yeah, it just started to drift. As it started to get, it's still not that bad, is it? It's right there, yeah. That's where it gets bad. But you know what? We're gonna make it work. By the time we get that big, by the time we route it with a giant, we have a giant chamfer bit. We're gonna route it with. It'll clean up and look really nice. So let's go ahead and let's go ahead and get this one off and square the end of the other one. And then we'll cut them both away.
So you're gonna get this.
Just with the board. See, I'm just hitting.
Yeah, we did exactly. Yeah, but don't put it down on just nothing. Grab some stickers. We don't want it down. And yeah, if you can put it over there to get some blocks. Where is that? We'll put it on that side. So we can bring the other one in here and then cut from the other side. Very good. There's not enough stickers.
Yeah.
Like 4 stickers. One by one work as a sticker. Oh, must be all the same thing. Good, it's good. Hands in there. Yeah, good. I like it. Make sure it's- Okay, you got it poured out of the way? Yeah, that's good. Ready? 1, 2, 3, up. Okay, we need to get that other one in. This will all be a good shape to use, if you look at how Flavia does everything.
Right.
Yeah, the 4x4s, you guys, let's get some stickers and get them in here. So maybe just take those 4x4s off of there and bring them in here. So get like those short ones. Put them a little long, yeah, like that. Yeah. That 4x4 or 6x6. Yeah, we'll put those, we'll take the stack of those off. You just stack those guys up. You won't need any of those stickers. Yeah, just put those 2 side by side and then 2 on top of each other. We're gonna be cutting those 2, and I don't think we can cut 6 by chunks.
How big's the blade?
Pardon me?
How big's the blade? You might be able to. No. You're gonna use that?
We're gonna have to use that. That's just Didn't like that cut.
So you don't like that blade? I was looking at those 62 blades last night and I was wondering about them.
Yeah, it makes a clean cut.
More for like miters.
Well, more for just a good cut. It's not that bad. Oh, good work, good work. Actually, that's good. Right in the middle. Good job.
You could probably shoot it more that way, or move this.
Oh, yeah, we're cantilever, so yeah, let's get this one. Yeah. That's perfect. Good?
Yeah.
On there? Right. So let's look at these ends. Oh, shit. Good looking end. You probably want to get rid of that. Like cut 5-6 inches back. What do we wind up with? Yeah, let's just see what we got here. What we got to work with. So we got 4 in there. Here we're gonna wind up getting about, we'll wind up with 17 foot. Cut this guy off. Let's see where we go from there. Oh, yeah. Piece of cake. Okay.
I measured at the mark that I made.
That's good. That's good. That's where I wanted you to make. Exactly what I want you to do it. Exactly. So get rid of that check. We don't like that knot. What did I say? 5.5?
6.
5.5. 2.
Oh, yeah, my bad.
That's all right. 2 to 7.5. And any chance you get, laying out square with a framing square, inside of the square, rather than the outside square. If you can, it'll give you square. This is the best square. It's better than the outside. Always use the inside. That's 5.5 inches over. Okay, remember, it doesn't matter all that much as long as we cut square. We're just squaring up the same. So these beams are 6 by 10s, which means how many board feet per running foot? Yes. Why?
6 times 10.
Exactly. So, right, 6 by 10. So 6 by 10 over 12. 6 times 10 is 60. 12 into 60 goes 5 times. So for every lineal foot, it's 5 board feet. So it's 18 feet. That's 90 board feet. At $3,350 $1,000, that's $335 a board foot. So each one of these is about 300 change. It's tight. No, not good enough. Can't move. Like that. That's 600 feet tighter. Then get me out of that.
In the classroom.
Yeah, this clamp is not working. Thanks, Evan. Yeah. Like hand screws anyway. Joe gets the hand screws. So, you could, if you were doing this on a job, you'd probably, I don't know if I just eyeball this and cut it by hand, but because this shows so much and we're going to chamfer it, and pretty much, this is not like framing that's going to get buried, right? Most framing jobs, when you're framing walls, virtually everything you're doing is never going to be seen. It's going to get covered by drywall, stucco, any one of 1,000 things. But when you're doing beam work that does show, then it's a little bit. Yeah, no more of these. It's too big. No more than the 7 that are in there.
On that wall?
If I didn't have that thing in the way. If I didn't have that thing in the way, I'd put them like that. Much easier to get. Okay. I like it. Here we go. So since we have so many people here, Bobby, if you're gonna tail me like that, do me a favor and help me out with that. With that guard. Let's get it back for me. Yeah, that's a beautiful cut. Better? Oh, yeah. So brand new blade, 62. And you know what? Did I bring, do me a favor, would somebody go in there and get that Makita green thing to set this in? It's much better to set it in that. Oh, isn't that nice? Check that cutout. That is one nice cut. Okay, so we'll move. So would you guys grab this off, move it down that way? We'll make our other cuts down there. Get the angles.
Yeah.
Those things are. Yeah. Go ahead. Just like that. So this thing's got a little crown. So we have overbuilt this like crazy, right? And the reason why I overbuilt it like crazy, anybody want to know why I overbuilt it like crazy? Anybody have any guesses as to why I overbuilt it like crazy?
Why not?
Because I didn't want to pay to engineer it. And I didn't really know how to engineer it myself. I could have figured it out, figured all the calcs and stuff like that. So I just went big. I know for a fact this thing will take any span that you put on it. And I like the look of it. So we pretty much just engineered it by feel.
I got all your stuff over here, sorry.
No, good. So, all right. We got square ends on both of them. Let's see what our control thing is going to be here. So this guy looks like we should be able to get 17 out of that. No sweat. Any bigger when you get into some of these checks, well, we could go a little bigger. So 17 to 17 plus. And this baby. We're gonna get 17.2 out of those things, so 17.2. No, it's not good. Nice. Good. Here's a- show them. Make sure we get it. Run my computer in there so you can see a mag light. No, it's not. No, it's a tack light. It's 1100 candle power. This is nuts. Yeah, 1100 is insane. Everybody get your speed square. As long as they're the same, right? Yep. Wait, what happened? What? It's good. It does SOS and something else too. Yeah. Okay, that's all. Yes, we do. You get a tail for me and work up. Work my end. Not on my guard. Right. Work the guard. Both of us get what I'm doing. Yeah, you just stay, keep your hands away from the blade, but just like that is perfect.
Watch those
Away from the
fingertips.
work, right? So. Good looking cuts. I like that cut. Snappy, but no. Okay. What's that? Okay, we're gonna be this off. Okay, putting that on.
We're gonna stack it.
But before we do, I'm gonna measure this. Whatever this is, 7.2 or whatever. Oh, my pants fall off. It's 17.2, just under 17.2. At this stage of the game, it's gonna be 2 minus. Okay, so we need to get, we could just stack this on top of this and hang it over, but the things weigh so much, I don't want the cellars to collapse. So we need to get this off and that on. So let's get some stickers. We got stickers around here, all kinds of.
There might be
Put
some more
stickers
over there.
over here. Let's put this one right here. Lots of stickers. Good, good. Good, good.
There's like quite a bit of.
Okay, we get for these 4 guys. I'm just gonna put it right there on top of the stickers and don't trip on them when you back up.
Oh, yeah, I think I want this more, this one. All right, ready?
1, 2, 3, 3. Good one. Way to go, you guys. 17, just under 72. Now we get this one up in the middle.
Ready?
Good one. So you definitely got a tractor there to lift this thing, right?
Yeah, tractor or
Or-
forklift. Yeah.
Neither one will do.
We just have to let me know the Saturday we're gonna be doing it, and I'll have a grounds guy there to help. I think next Saturday, he said, right?
Yeah, give me a little bit. Ready? Yeah. All right, 17.2. Gonna need a little checking. It should be fine.
There's a flat shovel over there if you want to, and a normal broom if you want to sweep it up. Yeah, and then that's the trash bin right there.
Hey, do you know what you do if you have like a 20?
I think you look it up. They have books. They have Rafter books.
You think anybody actually memorizes that off the top of their head? Maybe, sure, people know, like.
The 4 and 12s probably.
Oh, those numbers, I bet if you cut enough roofs. I mean, I happen to know that 2 and 12 is 14.42 inches per foot of span. A foot of run.
Is that just from doing this project? Yeah.
I was gonna say something.
What happened to the other one? Wasn't there another one over there?
Oh, I like it.
Wasn't there a normal broom over there though? There was. I don't want to use it.
Yeah. Okay. This should be the last few.
Do you like sweeping?
Hey, who's gonna tell for me? You're gonna- You know what? Don't worry about tailing. This is a small enough piece. It won't rip off. It'll be fine. Should have. No, it's not bad. Somebody go take, find a tape in there and measure that 12-inch chop saw and see what it will cut. I don't think it will cut 6 percent, so really don't. I think we're gonna have to cut them out here. So, okay, so let's go ahead and sticker this on top of that. So get some boards on top of this one. We'll put them on top of each other. Wait, like this?
Yeah.
I was looking at
One of those nights, huh? I think the matcha's wearing off.
Again, just to be sure.
Forgot that line. Oh, baby. Those are exactly the same.
Nice. Good job.
How hard is that?
What a pro.
That's good. All right. Let's get it more hands. All right, be careful when you step over that. See that. 1, 2, 3. Oh. Did anybody measure for me? Can we just take this in? and see?
I don't think so. We're talking
I'll
about
just disconnect
something
it for
about-
now, I'm not putting it.
Somebody has our 12-inch to wall. It was out here, so either Jim or Pat has our 12-inch to wall. And, we could cut those with a chop saw. Should we cut them with a chop saw, or should we just go ahead and cut them? Let's cut them. That was my first.
It's not in one of the back, it's not in one of the back sheds or anything, you think? One of those back,
No,
no,
not the one I got open with the lights on.
okay.
I guess I could call Jim.
You think-
Let's cut it.
You think Pat has it for his kitchen cabinets?
You might.
Yeah.
I have it. Just we go on these two horses. Just grab one of them and throw it on there. I didn't mean throw it. Set it.
All right.
Just kidding. That's good. That's good. So this is a really nice end. It's pretty dang square. I mean, not pretty dang square. It's square. This guy's square. This guy's square. So I like that. I'm gonna leave that for a bottom. I like that a lot. And I think we're gonna find that in a bunch of them. So let's bring a couple more up here. Okay, so we got two posts. We're cutting at 6/8. Okay, stop. We'll do two at a time because two are going to be the same dimension and two are going to be different. So this one looking really square. Really square. Yeah, I'm happy with that. So happy with that. Okay, so post is 6/8. The other one's 10 inches tall, right? Which makes it 7/6. So 6/8. And somebody do me a favor, Dave, would you run in and grab my pencil somewhere in there? I want to get a circuit, some marks with a pencil. 7mm. Pretty good light in there. So what we did was we did the staircase just to show people how to cut stairs, right? The landing, stuff like this is part of framing. And then one semester I did all those handrails, the CT110 class. That was really a lot of fun. We had a lot of fun doing that. doing that, figuring balustrade centers.
Is 115 intermediate finish mark?
Yes.
Put TV up there. Put TV up on the second level.
That's the TV, what a good idea. So what did I say? I said 7.6, right?
7668.
You're right, 7.668. So let's see where these guys are at. When I say, let's see what these guys are at, let's see what the posts look like. So 6.8 right here, I think is really close to that knot. So let's make this a 7.6 one. Couple long ones first. Make that 7.6. Let's see. That's going to hit this one. Let's see if we can miss that big old knot. Yeah. Okay, so just to reiterate, one of our posts is 6.8. One of our posts is 7.6, which is 10 inches higher. That's what we want. We want that 10 inches for 5 feet. We don't want 2 inches per. That's 2 and 12. 2 and 12. So 7.6. 2 at 7.6. 2 at 6.8. 6 by 6. Okay, cool. Somebody bring a speed score?
Yeah, there's two right here. And this camera is not doing a good job of focusing.
What's it not doing?
It's just out of focus a lot.
Yeah, I know, it's been doing that, it's weird, but not all the time,
No,
just some.
it has kind of good runs where it's all right, and then really bad ones. Get closer.
I'd really
There
just
it
like to
goes.
cut this.
There it is.
That thing is just so hard. So let's do something different. Let's do something a little different. Let's see if we can't save some time. Put these together at the same time. Right. Okay, get a piece of wood. All right, did I get you? Yeah. Yeah, I'm sorry. Knock those together. They together? Yeah, looking good?
Yep.
Still look good?
Yeah.
Yeah, great. Remember, I gotta have punch from the back too, so don't miss me. Yeah, so grab one from over there, hopefully one works.
You get pinched or something?
Yeah.
Good, very good, very good. Very good. Okay.
Little kiss. Yeah. No blood.
No.
Good job.
Whatever.
You might.
You changed yourself.
Seem like that.
Oh.
What happened?
You might need it.
These guys are just pinching themselves over and over again.
Warm no foul. So after we cut this one, we'll cut one more, and then our big cuts, 6x cuts will be done, which will be cool. Somebody want to shine that flashlight for me? Didn't I have two clamps here? Are they these two?
I just brought these on.
Yeah, this one, I don't think this one works.
I mean, they.
Oh no, he just brought
The
that.
other, I brought them in from.
You did? Oh,
Yeah,
Yeah,
those
that
are
other
new.
one works.
good, thanks.
Use old Betsy.
No, it's too big.
What are we doing? I'm gonna have to, man. Gotta put it on for show.
Hey,
huh?
leave Bessie alone.
I think we gotta put it on for show.
Yeah. Just
Huh,
for,
you can't get it to clamp.
It's got a technique.
just for moral support. Put Bessie on there. Yeah.
That's the pine plant. This plant costs like $128 a piece.
Oh,
And Jim, somebody has borrowed them, and so now we have like.
If you just,
Three.
this thing, you have to put it at a little bit of an angle so it slides down this thingy, and then you can clamp it.
the
It's
technical
like
term.
so. What? If you don't, it'll be weird. It should be all right.
You okay?
Oh man, we just killed the focus.
No. I figured it out. If you're within like 5 feet, it's okay. But if you go back further than that,
Here it
What
goes.
is Rodney Dickey's computer? Isn't it like a nitro?
it's SBCC, IT department.
Oh.
They're all
No,
Dells,
don't hold
except
it.
for in the computer labs.
They
They
gave me
got
their own,
The
but-
problem is that I can't.
they got
can't
alien guys in one of the
damn-
computer
No,
labs.
they have good stuff. Nice.
Very nice. It's the moral support that she provided.
Blockchain, that's okay. Do that. Okay, let's unclamp everything. We'll put two more up here. Now we cut these, what? 7/6, right? Yeah. You sure is. Oh, yeah, you guys need, idiot, guys and gals. Need these. Let's go in the pants. Let's go. Hang on. You. Want the stickers on the side?
Yeah,
What are they
that's
supposed to be? 7/6.
7/6.
good.
All right, so move those and stack them up.
Over here, over here.
No, just put them on top of it.
All right.
One spot, the rest-
Aggressive.
rest of places you can get down.
Those new steel toes.
1 inch. Set it on. Very good, very good, very good. Very good. Okay, no spots. Good.
More that way. There you go. Yeah, there you go. Get them together.
So you can see some of the stuff I want you to just be aware of, and if you haven't done this before, We got Zoom people happening?
Yeah.
Right, Ben?
Yeah, you're good.
Is what's happening is you want to use economy of movement, right? So we want to hopefully move these the minimum amount of time, the shortest amount of space. So you try to plan out how you're going to cut things and where you're going to put things, so you're not moving them more than once, especially heavy beams, right? So are these square? We ascertained these are square?
Yeah, I go.
The good square, you got to square to them?
Oh, swear, oh, no, my bad.
So let's just see. So it's been cut, that's really rough. And somebody want to see, get a screwdriver, something to pull these staples for us? Yeah, I like those ends. Those are good ends. Need a screwdriver or a decent blade knife, if they're not going to bust like mine. Here. Square. Okay, so what are we clamping this for? Give me that BZ.
Oh, wow. That's a good way to say that you don't know what it is. Go on, help me out, see. What is it?
Can't do this shit. I'm getting. That tape, please. And is there a pencil underneath that board? Mechanical. Did I tell you guys about my foot? My right foot. So I'm moving around pretty good. So 6'8". So Saturday morning I played golf. And when I got in my truck or my car, I was wearing my Hoka slides. You know what those are? Like after soccer slides or whatever. And it got me up about that high, and I have this cutoff post in my carport. It's really right where I walk around it all the time. But I stepped on it. It's raised 1/8 of an inch, and that 1/8 of an inch turned my ankle. And so I turned my ankle. It was very painful. I turned my ankle before I know what sprained ankle's like. I hobbled a little bit, sat down, I palpated the ankle. It wasn't. Because when I sprain my ankle bad, it just immediately balloons up, right? It wasn't ballooning up. I feel like I could just walk it off, right?
Oh, there it goes.
That's the lighting.
So I
Had the magic touch.
played 14 holes of golf. I walked 7, and it was agonizing. I couldn't walk anymore, so I put my bag in a guy's cart, and I played another 7 holes. And then I called the guy to come get me, and took me to my car. I took my shoes off. I couldn't accelerate or brake with my right foot. I was in agony, man. I had to throw it on my left foot, got home, and it was in so much pain and thinking, what an idiot. Sprain your ankle and go walk 14 holes, go walk 6 miles. Good idea. So after a day of icing and elevation, and then Sunday icing and elevation, Monday I felt pretty damn good. And Monday I went and got an X-ray. I got no cracks on the head. It's Tuesday, and I'm walking on it just fine. But it was amazing to me how it could hurt that bad. And the moral of that story is if you think you sprained your foot, don't go walk 14. Don't. Promise I'll never do it again.
Until the next Saturday of golf.
Well, I, yeah, I know. It's hard. Thanks for this. Where's that handy at? Carpenter's pencil?
No.
Yeah.
Yes. You got hot chocolate?
Yeah.
Didn't they always have hot chocolate? 3.
Oh, so you make that thing look good. That's why I put this right in.
Is this the one that doesn't? Yeah, we want that. Do it. Let's use the BZ clamp. That's probably all we need. We get that one. Yeah, these clamps. Oh, I love these clamps, man. Just the best. You still looking good down there? Maybe almost. It's still almost. Well, which one? Which one you
Just,
showed?
just by,
What is it?
just by feeling it, it's like a 30-second.
Yeah, no.
That's precision right there.
Feeling it is one thing, but when you put a straight edge on it, do you see any air? No, you don't see any air. That's what you're looking for, is any air. If there's any air, then something's off. These things have a line. They're not dead straight. That's why they're not going together. Dead straight. But that's not gonna play this. We're gonna be just. So we'll need somebody to hold that. And huh? Okay, somebody's gonna do the guard for me. There you go. Hold them when they fall. Pull up and you'll find the hole. All right, let's drop that blade all the way down, put it in that, dump the sawdust on the top of that. Let's get the clamps back in there. we'll have time to show you the router and stuff, and then we'll,
I want you.
next week we'll dress everything out. And the following, and next Saturday, we're gonna go. All the taps go back to the end, all that one goes in the corner. Speed squares, everybody knows where that goes, framing squares goes in there, there's somebody's, carpenter's pencil, thank you very much. You know what, you guys, let's do this, that's all right. Let's move these down. Because we're actually out there. What we might want to do is we'll just leave these here. Let's put a couple more stickers and we'll make stickers wide enough to do 2 and 2 of these guys. 2 on the bottom, 2 on top. So stack too high, but over there under the roof. So grab a couple stickers from somewhere else. No, we could. We should, yeah, we're gonna move all that stuff in too. So let's get the tools in first. Get the tools in first. Yeah, we're gonna go back into the shop for a little bit. I'm gonna show you that router. Then we need some new stickers over there. We're gonna move all 4 of those on top of each other, and then we will move these guys at least so they're not out to the edge of those routers. So, we're gonna turn you off again. You Zoom people, we're gonna turn you off again, and then we'll turn you on back in there, okay?
Sounds good. Thank you.
Showing late tonight. Someone shows a lot.
Ah. Okay, gang. We're gonna get you set back up here. All right. Start video. Okay. Hey, everybody there? Cool. I don't know why I'm here in two spots, but here I am. Back again. Back again. So we're just moving some stuff around out there, and then everybody will come back in for just a little bit, and then we can say goodnight to each other. Not for a little bit. Just a little bit. It's hot out there. It's hot out there. How are you guys? How's everybody over there in Zoom land? Pretty good?
Good.
I wish you guys were here, man. The more the merrier. That was fun.
Looked like it.
It's going to be even more fun. Wait till I show you before we part company tonight. I'm going to show you these bits I got in this this router. I'm going to put into use, and next week we'll rough out our rafters and we'll do all the chamfering. That'll be fun. It'd be a fun time for all to be had. You guys are going to go, God, I wish I was there. I wish I could have got there.
Rodney, is
sawdust on me.
Rodney, is a beam saw just a circular saw but bigger, or are there actual differences?
No, that's exactly what it is. It's a giant circular saw.
Got it. Thank you.
And I'm not sure if it's worm drive. I think it is a worm drive, that saw. They're usually slow startups. They don't go right to RPM. They have a magnetic start, so they start up a little bit slower and they get to full RPM. It's a lot of blade to turn. And in retrospect, I probably should have gone with a 32-inch, the 32 teeth rather than the 60 teeth. It's pretty fine. It did give a fine cut, but it did drift just slightly, but I don't think enough to cause us any problems. And I can square it up with a belt sander too, just tune up the ends. All the ends aren't going to show. You just figure one end, we have a really good square end on the post going down. The ends on the beams won't really matter because we're going to chamfer the heck out of them. So you won't see all that much of them.
Why does more teeth translate to more drift?
I'm sorry, say it again, please.
Why does more teeth translate to more drift?
Why does board feet translate to what?
More teeth translate to more drift.
Oh, it's harder to cut.
Mhm.
There's more teeth to cut. Consequently, you get a finer cut, but it takes a little more energy to cut. More teeth are cutting, so the finer. Try to figure out I can answer that. When you've got a 32 tooth, which is almost half of the 60 tooth, you have that many less teeth, so you're going to be cutting faster. You're not going to slow the saw down as much. You will cut probably easier to shear, whereas that multi-tooth blade, as it works really hard getting to the cut, it's also a thin blade. It's going to drift. It seems to have drifted just slightly at the end of the cut. The 32 tooth cut would have cut faster and not necessarily cleaner, but it would have cut it faster and rougher, and maybe no drift. We don't know. It's a pretty big cut anyway.
What kind of use case would you have for a 60 tooth blade?
Say again, please.
What kind of use case would you have for a 60 tooth blade?
For a beam saw,
Mhm.
fine cuts. So that's a cut that's way better cut. Needs no sanding. We'd have had a bunch of saw marks that have been a way rougher cut, and we're doing exposed beam work. You'd want a finer saw like that for exposed beam work.
Got it. Thank you.
No sweat. Oh, you brought that in here. Okay, that's good. Yeah, that's good. That's a good place.
The lights are off and we just didn't.
No, that's good.
Lord, we didn't
No,
want
thank you. Thank you for doing that. And we'll just leave that in here because I don't think nobody's making stuff in here except me. Okay, so I'm going to pin myself. Everybody saw that, right? everybody at home saw what we did. And I don't know that I'd do it any other way. I mean, if we were doing it there and we were working during the day and we had a crew doing it, so that would be, you could do that with it. You couldn't really do that with a 2-man crew because you couldn't lift those 8x16 beams. That would just be a bear. Now, if you had a genie lift with 2 guys, a hand, like they're a hand, it's a manual forklift, basically a genie lift. I showed it to you last week. With one of those on site, you could conceivably, 2 guys could walk it over to a genie lift, and the genie lift could roll it, and the genie lift could raise it. But given the site that we're at, the mulch and the dirt that we have to roll over, the genie lift is not going to want to roll over. We could use a genie lift on the slab to raise it. In this case, we're going to have a forklift to raise it, which is going to be great. But you'd have to take into account moving that material over that ground, and I think it'd be a 4-man crew. So we wouldn't do it probably too much different than we did it, other than we'd have, everybody would be cutting, and say 2 guys that were messing with the big beams, cutting them. You'd probably have the other 2 guys roughing out the rafters or something like that, just trying to stay busy. But I think we did a nice job. We did what I wanted to do, which is cut the posts to length, we cut the beams to length. And now, next week, I discovered, thanks to Jim, discovered this router, this brand new router. It's a Triton Plunge Router. Never heard of it. Triton dual mode Plunge Router. I needed a router with a 1/2-inch column. That's the column. That's this part of it in the middle. You can see it's a piece of metal that's slotted 4 places. So as it tightens in those 4 places, it tightens on your bit. It grabs your bit really well. And when you've got something turning a bit this size at 16,000 RPM, you're going to want it really chucked up into your well. You're not going to want it to come out. You never want any of this stuff to come out ever.
Wow.
Yeah, that's a big chamfer bit, huh? And that's what we're going to put. I have one of those beam ends I'm showing you. That's what we're going to put. We're going to go along the edge. We're going to put the face on the end of the beam, and we're going to put a chamfer all the way around on the ends of the beams. This big chamfer. And we need a 1/4-inch collet to do that. This 1/4-inch collet. We'll take this router bit, like so. Now, we're going to also chamfer the posts, edges, and we're going to chamfer the beam edges. So we're not going to use this giganto chamfer. We're pretty much going to use that giganto chamfer just for the end of the beams. I wanted to have a giganto chamfer, but a smaller, more subtle chamfer on all those hard square edges, posts and beams. When we can get to them, it's going to be this 45 degree. Now, chamfer bits come in 30 degree and 45. This is a 45. I prefer the 45 degree bit. That's a 1/4-inch column. That's a 1/4-inch shank. So 1/2-inch shank, 1/2-inch column. All of your routers that are bigger than that Akita and bigger than laminate trimmers should be interchangeable with a 1/4-inch collet. Quarter-inch collet. Yeah, cool. So we'll use a 1/4-inch collet for this bit to do some of our detailing on these guys. So if you can picture this won't be a beam end. This is a post end, but picture this as a beam end, only about like that. We're gonna come on the end of it with the router flat, and this will roll and we'll chamfer. We'll put this 45 all the way around the end. So it'll be cut in about like that. And 45 back. So if you're not getting it, this isn't working for you, I promise you, you will when you see it in action. You will get it. So this is a plunge router, and it does all kinds of great things that plunging does. We will fix it. We won't need the plunge part of it. We just want a nice big router that I can grab a hold of and hold on the horizontal. This is a pretty interesting tool. I haven't really explored it too much, but it also comes with a flattened deck that you can make a router table. You can mount your router in and set that on. I haven't read it yet, what they want you to set this on, but it's a router table. So you can move stuff across your table, across your router. You know, traditionally, routers move across the work. Versus the shaper. Shapers are just upside down routers. That's a shaper over there. It's got a router mounted, and then you move the work across the knives. And with this router, we're going to move the router across the work. And then the small chamfer, we'll use this baby, which is cordless and has coordinate shank. And believe me, I would have done that one cordless if I could have got. I just want a really big chamfer, which is going to really soften that big beam, and it'll just look. The thing about the details that we're going to do with those beams and posts and beams is it's not just going to be a regular structure that somebody threw up. You're going to see it. You're going to see the quality of the wood, the DF #1, Select Expose, free of heart center. This isn't just stuff that somebody came out and got out of the lumber yard. This came from a mill to my spec. So when I said 6 by 10 by 18s, they milled that to my spec. Same thing with the 6 by 6s. That's why when you look at the stuff that we just cut, you'll notice it's all completely square edged, right? Now, if you go buy stuff at the board store, 2 bys, 4 bys, 6 bys, anything like that, you're going to have an eased edge. That edge is not dead square. That's dimensional lumber with an eased edge. So you can tell when the lumber's been custom milled, it's got a square edge. They don't ease the edges. You get a square edge. Which we'd rather have anyway. We can put, and we're going to put our own eases. We're going to put this small chamfer on those posts. If you can picture these uprights. These will get a 45-degree chamfer in all the corners, which will soften the corners, but it won't make it look round, not like that pergola over there. It's just going to, it'll just ease that edge, but it won't be a rounded edge. It'll be a nice, clean 45-degree chamfer edge, which is going to go along with all the stuff that we're doing after. Any questions? Questions at all? Okay, so if you have my class on Thursday, there's no, it's Veterans Day, there's no class. If you're interested on Thursday and have any time, shoot me a text or an email or a phone call or whatever, and let me know, hey, I'm willing, because I may come over here and do some work for a couple hours. Just don't want, because it's date, you know, be daytime, and I'll have a little bit of time, and just to get a little further ahead, so that when we meet again here next Tuesday, we'll finish up the routing and the cutting, and hopefully I'll have a bird's mouth cut on a rafter and done some mock-ups, and I'm hoping to be that far along so we can go ahead and cut the rafters to length, cut the plumb cuts on the rafters, cut the bird's mouths on the rafters, maybe cut the blocking, probably not, because remember, if you remember my description, my hand waving description, what I'm planning to do is the uprights, picture the uprights, right? The headers, those are all dropping into our honking big $95 column caps. And those will all be, sitting there. And then we're gonna put roof rafters on them. And the roof rafters are gonna have that bird's mouth, that notch out for both the beams, right? That's gonna be done. We're gonna be able to drop those on, toe screw it, and then throw a block against it, hit the block, put a rafter against the block, blocks on both the headers, called freeze blocks. Put a rafter against that, locked into the bird's mouth, lock it down, put a block against that, right? So before I pre-cut those blocks, we'll have a chop saw out there and we'll cut the blocks out there just to make sure it's like, oh, because those blocks have got to be perfect because the rafters have got to be perfect because the rafters need to break exactly 2-foot centers so that our roofing works out. Because our roofing comes over and then laps right at 2 feet and then laps right at 2 feet. And then we have that wiggle board to put on. So as simple as this structure is, there's nothing simple about it. I mean, was that simple? I mean, yeah, in principle, yeah, we just cut 4 boards. No, we cut 6, right? And we didn't cut 6 boards, we cut 6 timbers.
Are you gonna need to angle the edges of the freeze blocks to meet the slope of the?
Given a 2 and 12 pitch slope, I don't know what to see. It's a minor pitch. We might be able to just set them flat and have them work. And if not, I'm hoping to we'll bring our little table saw ceiling pieces. When we put this together, we're going to be armed to the teeth with tools. So if we need to, we can just throw this, or perhaps I'll go ahead and rough cut some blocks and put an angle on them. I'm just not sure. Part of this is that bringing you all along with me doing this is completely different than if I was just doing it, right? So I've got to rethink everything I do and doing it this way. And I think we're all going to have a good time doing it, and you're going to have something that forever you're going to be able to go, hey, let's go see that shade structure, man. We did the slab on this. And any other questions? Come on, more questions? No more questions? Next week, I'll see you here. Got to yell.
Are you?
No, we're good. So I'll see you here next Tuesday. If you have my Thursday class, don't come. It's Veterans Day. Come tomorrow. And if you can't come to take the test with Jim tomorrow at 6 o'clock, you need to email him and ask him for a PDF. Okay? Don't forget. Email him if you can't come. Let him know. Email him to, this would be the best one. Jimbo@yahoo.com.
Thank you, Rodney.
Next week, or maybe see some of you sooner than that. See y'all.
Bye.
Oh, did I put the recording back on?
Yeah, I did.
Okay.